Once again, welcome to another lesson, Senior 5, Pure Mathematics, for the case of the Ugandan education system. I am, once again, teacher Agaba Kosma. For those ones who have not been following our lessons, it's good for the lessons from the first one, so that you can have a connection of how we are moving. At Back Science Education Consultants, we are saying your child must achieve the goal. That's if you're a parent. If you are the student, you must achieve your goals. There is no reason why you should not. Much as there could be a pandemic or a lockdown or whatever, learning must continue taking place. That's why we provide online teaching, Zoom lessons, guidance and counseling. If you are there and you are not feeling okay in one way or another, we have specialists in our consultancy. Just get us, Back Science Education Consultants. You'll be getting our contacts. Subscribe to our YouTube channel, then you always be notified. If we are to continue with the lesson, we have done a lot as far as trigonometry is concerned. Now, for reference, you can check in the previous lesson. The video is there. When you check, you get it. But as of now, we can get certain relationships from what we call the Pythagoras Theorem. Even when you go to primary and you draw something like this, a right angled triangle, where this is the longest side and this is 90 degrees, and you name it C, A, B, students will tell you that A squared plus B squared is C squared, and they will tell you this is Pythagoras theorem. So that if A is 3 and B is 4, then somebody has the capacity to get C, that 3 squared plus 4 squared is C squared, and this would be 9 plus 16, which is C squared, and this is 25 equals C squared, and therefore our C would be the square root of 25, which we will take as 5 sixths length when we take the positive value there. That's how we have the capacity to solve that one. That one comes from Pythagoras, a good scientist that helped us solve this. Now, we want to move to his theory. From this, we prove something here in trigonometry. Let's go. If we have that circle, and maybe you can make quadrants. You can make quadrants. Let's do in the first quadrant. If we have an angle theta here, from here to here is the radius of the circle. Okay? That is I. So, if we can make this one, from here to here we can call it X, and from here to here we can call it Y. In terms of R and theta, I want to get X and Y. Let's go. What is cos X and sin X? Cos adjacent of hypotenuse. Therefore, cos theta is adjacent, which is X out of R. So if I want X, I can cross multiply R this side. So we have X equals R cos theta. Then if I have sin theta equals opposite of hypotenuse, that will be Y out of R. You see that when I cross multiply R this side, I will have Y equals R sin theta. Therefore, this is R cos theta and that is R sin theta. So if we did this, we want to go to Pythagoras now. This is R, this is 90. As from there, this is why what we have said is R sin theta. This is r cos theta. Let us substitute this one in our Pythagoras theorem, so that this squared plus this squared equals that square. So this will be r cos theta squared plus r sin theta squared equals r squared. Let's square. When you square this from indices, this will be r squared cos theta squared, which we write as cos squared theta. This will be r squared sin squared theta, and this is equivalent to r squared. So if I divided both sides by r squared, here I would remain with cos squared theta plus sin squared theta. R squared over r squared is 1. This one is an identity. Is called a trigonometrical identity that is derived from the Pythagoras Theorem. We use this identity quite often in solving many trigonometrical equations. Note, it is not cos theta plus sin theta equals 1. No, it is cos squared theta plus sin squared theta equals 1. But from this one, we can see that already you can have, maybe I call it equation 1. If I take cos squared the other side, then you can have sin squared theta equals 1 minus cos squared theta. Or if I take sin squared theta the other side and remain with this, you can have cos squared theta equals 1 minus sin squared theta. We shall use all these ones in solving some equations. We don't stop there. We can prove some other thing from this. Let's look at the equation 1, what we have called equation 1. And we are going to divide that one, divide the equation 1 by cos squared theta. Let's divide by cos squared theta. So we shall have cos squared theta plus sin squared theta equals 1. We are dividing by cos squared theta, cos squared theta, cos squared theta. What do we get? Cos squared now divided by cos squared. This is 1. A sine over a cos is a tan. So the sine squared out of cos squared is a tan squared theta. So this is plus tan squared theta. And this is equal to 1 over cos squared. Remember from our first lesson that we said that a sec theta is the same as 1 over cos theta, meaning cos theta is 1 over sec theta. So therefore 1 over cos squared theta, if we square this, it will be a sec squared. So it will become a sec squared. So 1 over cos squared, this is a sec squared theta. This is also another identity that is very important in this trigonometry, and we shall also use it in solving some equations. Also from here, you can see that if I take this one the other side, then tan squared theta minus sec squared theta minus tan squared theta will be equal to 1. Okay? If I take 1 the other side, then I will always be having tan squared theta equals sec squared theta minus 1. All these ones can be derived from each other. That is our second trigonometrical identity that we are deriving from Pythagoras Theorem. Let's go. We can have another one. We cannot finish these ones, but let's do one more. In our equation 1, here we divided by cos squared theta. Let's divide by sin squared theta. So equation 1 divided by sin squared theta. What does it give us? Let's go. So we shall have cos squared theta plus sin squared theta equals 1. So if I divide by sine squared theta, what do I get? Cos squared over sine squared. The cos over sine gives us a cot. So this is cot squared theta plus the sine squared over sine squared. That is 1, and that one gives 1 over sine squared. Said 1 over sine is a sec, a cosec. So therefore this becomes a cosec squared theta. So therefore we can already say that 1 plus cot squared theta equals cosec squared theta. This is another identity that we can employ in solving some trigonometrical equations. So this is the third one that we can use while we are solving trigonometrical equations. We are going to have examples and we see how we employ this one. Let's go. Examples. You can first write them, then we do at once. Solve the following. Yes, we are solving. You have to mark the range from negative 180 to positive 180. 2 cos squared theta plus sin theta minus 1 equals 0. 3 sec squared theta minus 4 times theta minus 2 equals 0. If it was the previous time when we had not studied this would rather look hard, because this one is giving us a cos squared, this is giving us a sine. We would not put it in trigonometry, we would not do hard. But now we know we can change from a cos squared to a sine squared. Then we have the capacity to now solve a quadratic equation in a sine squared. Since we have this cos squared which can be changed, then we solve and we are able to get the values of theta. Alternatively, same as here, where we have a sec and a tan. Because we know a sec and a tan, they are related in given equations up there. So we can begin. We can begin on the first one. I'll just press these ones here so that they can help you. These ones, they help you. Since you may not be having them in your head, but with experience and with more working, they will just be off head. So we have a 2 cos squared theta plus sin theta minus 1 equals 0. So how do we do this? We said that the cos squared theta is 1 minus a sin squared theta. So where we have this, we can replace with this. So this means that we shall have 2. A cos squared has become that 1 minus a sin squared theta. Then plus a sin theta. Then minus 1 equals 0. Let's go. This is 2 minus 2 sin squared theta plus sin theta minus 1 equals 0. As we correct right terms, these 2 will be corrected to this. So we shall have minus 2 sin squared theta, then plus sin theta. Then this 2 minus 1 will be plus 1 equals 0. Then what we have the quadratic in terms of sin theta. Majority of you prefer removing this negative, much as it has no problem. So we can remove it by dividing by negative here, and negative there. So this gives us 2 sin squared theta minus sin theta minus 1 equals 0. And you know how we solve this one? We say that sin theta equals minus b, maybe I write minus b plus or minus the root of b squared minus 4ac over 2a. You are using to this, but we shall not always be quoting it. It shall just be substituting. You have to get used. And this is equal to, our b is negative 1, so minus that will be minus of minus 1 plus or minus the square root of b squared, that's negative 1 squared, minus 4, our a. Our a is 2, then our c is negative 1. Then the whole thing out of 2a. 2, then a is 2. And when you press the calculator, we shall have sin theta, equals 1, or sin theta equals negative a half. So when we reach there, I think there you know how to handle. So how do you handle when sin theta is 1? If sin theta is 1, then theta is the sine inverse of 1. So theta equals sine inverse of 1. What's the sine inverse of 1? When you press on your calculator, please press it. You should actually be knowing it in your head. Somebody knows that this is 90 degrees. Somebody knows the sine inverse of 1 is 90 degrees. Then of course you can have more. This one is in the first quadrant. Sine is again positive in the second quadrant and etc. Okay? Then if sine theta is negative a half, then theta is sine inverse of negative a half. And we said you first leave negative a half. You look for the principal angle in the first quadrant. Okay? You know, since sine theta is a negative, then the sine will not be here and here. So the angle that you get will be here and will be there. So what is sine inverse over half? The sine inverse over half is 30 degrees. Sine inverse over half is 30 degrees. But in which quadrants? It is this one and this one. Meaning this one, our theta will be from here to here 180 plus 30, which becomes 210 degrees. Then if you also do like that one, which will be 330 degrees. Then our range, we have negative values. So we can also say our theta will take this direction and we have negative 30 degrees. And when you also take from here to here, that will be 180 minus 30 in the negative, which is negative 150 degrees. And therefore, if you are to check from negative 180 to 180 degrees, the values of theta that we have, the one that qualifies to be in that range, is this one and this one. These ones are beyond, and that one. So therefore, our value of theta will be negative 150 degrees, negative 30 degrees, and 90 degrees. Theta has very many values, but we are saying that in this case, we are taking only those ones in that given range. Hope you see how it moves. It all starts with a cos squared, but because we have studied that a cos squared is 1 minus sine squared, then you can change from that. We move on. We go to sine squared. We solve a quadratic equation in sine theta. Then we are able to get all these values. Remember always to give all the angles in the range, because we always award such angles. That was number 1. We can do number 2. Number 2, we have a sec. So when you check, the sec will fall in here, the sec squared and the tan squared. So the sec squared is 1 plus tan squared. So we shall say from sec squared theta equals 1 plus tan squared theta. So this one we shall have 3 into sec squared, which is into 1 plus tan squared theta, then minus 4 tan theta, then minus 2 equals 0. If we open the brackets here, this will be 3 plus 3 tan squared theta minus 4 tan theta minus 2 equals 0. So this becomes 3 tan squared theta minus 4 tan theta. This is 3 minus 2, which becomes a plus 1 equals 0. So what are the values of tan theta? So our tan theta equals, it has two values because it is quadratic, by the way, remember that, equals minus b minus of negative 4 plus or minus the square root of b squared minus 4 squared minus 4 into a. A is 3 into c. C is 1. Then the whole of this over 2a, where a is 3. Then when you work out that one, equals 1, or tan theta equals a third from solving that one. So if tan theta equals 1, what's the value of theta? We know the tan inverse of 1. So this one is in the first quadrant and in the third quadrant. Remember, all of them are positive in the first, only sign positive in the second, only tan positive in the third. So since this tan and this positive, this one is in the first quadrant and in the third quadrant. But when you take the angle in the third quadrant, it is more likely to be more than 180. I can show you. So you can have this. This is our angle, and actually theta will be 45 degrees here. So this is our 45 degrees, and this is our 45 degrees. So when I take this direction, the 45 will be correct. When I go beyond, it will be more than 180. So if I move from here to there, so that angle will also be a correct value of tan theta, and it will be negative 135 degrees. So we already have 2. So if tan theta equals a third, what is the value of theta? So you also go, it is also in the first and in the third, because it is also positive. So theta is tan inverse of a third, and this is equal to 18.4 degrees when you take the tan inverse of that. And then when you draw to get where this angle is, it is here. So this is 18.4. So if you are to get the whole of this angle, it will be 180 minus that in the negative, and it will be negative 161.6 degrees. So therefore, another one is negative 161.6 degrees. Other values are likely to be out of the given range. Therefore, our values of theta will be negative 161 degrees, 0.6 degrees, negative 135 degrees. Then we have 18.4 degrees, and we have 45 degrees. So it's all about tackling this, and you look for which identity can I put in to get this. By the way, you have to remember the future is brighter, but it will be enjoyed by those ones who will be there. So wherever you are, try by all means to keep safe. Keep safe in a way that COVID kills. We know COVID kills, but AIDS has finished a very big number of people. We should not only focus on COVID, there are also other killer diseases that we actually know the people they have taken. So take care of yourself. The future is brighter. Nobody should deceive you so that they can ruin your future. Let me give you a few numbers so that after doing them, you can send them to our numbers, and we can get to you for the responses to see how you have done it. So you can have this exercise to do. The exercise, sort of the following. Sort of. Yes, solve these ones. 4 cos squared theta plus 2 sin theta equals 4. The second, 4 cos squared theta minus 24 cosec theta plus 39 equals 0. And the third one is sin squared theta plus 5 cos squared theta minus 3 equals 0. Do this and can submit to any of our numbers there. Our email address is there. And don't forget to go to our YouTube channel, Back Science Education Consultants. Subscribe so that you can always be notified. I have liked your presence in my lesson, and actually my lessons. Don't miss another time. Let this YouTube channel be your daily classroom.